अलग हाँ मैं उनको कॉल कर लेता हूँ सर. He will chair the session. So we have Shri A.K. Mishra ji. He is a managing director of Magachu Hydroelectric Power Authority, Torangsa, Bhutan. इनकी खासियत ये है कि ये जो प्लांट है ये जो बनाया है इन्होंने एक बहुत बड़ा हाइड्रो प्रोजेक्ट है ये. एंड ही इज मैनेजिंग डायरेक्टर ऑफ दैट हाइड्रो प्रोजेक्ट इन भूटान. And the cost is about 7 crores per megawatt. I think it's very, very reasonable cost. So I request him to come to the dais. He's already on dais. We have Shrey Saxena, he from Grow Diesel. Basically, they are making diesels from the waste. Whatever the waste is there, they produce from that biofuel through that. And recently, they got an award from the British royal family also for the good works which they are doing. We have Sangeet Jain. संगीत जैन जी जो काम करते हैं एक्चुअली वो आई थिंक हमारी इंडस्ट्री के लिए बहुत इम्पोर्टेंट है. जो भी वेस्ट गैसेस हैं जनरेट होती हैं इंडस्ट्री में उससे ये बायोफ्यूल बनाते हैं. जितनी भी गैसेस हैं रिफाइनरी में they make ethanol, not biofuel, ethanol from that. So definitely taking care of the environment and giving us leverage to produce green gases or make this environment clean and green. So with this, I hand over to Mr. Mishra for the proceedings.
First of all, I thank all the organizers, Agrawal Saab, and sponsors for inviting me and giving this opportunity to be with you. With me on DAS, besides Mr. Agrawal, we have A.K. Mishra ji, who has been introduced. I think he will, Sangeet Jain Saab. Shrey Saxena is from Grow Diesel, which is a very popular and known company. Mr. Sangeet Jain will be, Mr. P.P. Mao and Mr. Sangeet Jain will be giving a small presentation on how he captures the gases. I will be, after everybody speaks, we will have a question and answer session and the house will be thrown open for discussion. And that is where I will jump in a big way. So, I think we should start with the presentation. That will be most interesting to leverage the session to some height. Thank you.
Thank you very much, organizers, and for giving this opportunity. I would like to share what we are doing at LanzaTech and where we call ourselves a carbon recycling company. LanzaTech has developed a technology which is based on a gas fermentation platform. अगर आप कंपेयर करना चाहें तो एथनॉल इंडस्ट्री जहाँ शुगर फर्मेंटेशन होता है बैच प्रोसेस में, LanzaTech में गैस फर्मेंटेशन करके कंटिन्यूस प्रोसेस से एथनॉल बनाने का प्रोसेस डेवलप किया गया.
ठीक है, डिस्क्लेमर सबने पढ़ लिया.
ये चीज डिस्क्लेमर पे ही रुक गया. धीरे चेंज हो रहा है, चेंज तो होगा.
डिस्टेंस आप कर दो.
Next कर. So what we believe is carbon is very precious. It's not just the diamonds which are precious as carbon form, but carbon is precious and it should be used very judiciously and always kept inside rather than spent left in the environment. Next. Next. So one of the things that we believe is energy can be carbon free, but there are other forms where you need carbon. Next. So aviation fuel is one जहाँ पे carbon का requirement है, liquid fuels will need carbon. Next. Then products that we used for our daily needs, जो भी हम कपड़े कोई भी प्रोडक्ट यूज करते हैं उसमें कार्बन है. नेक्स्ट. सो briefly I will share about the LanzaTech process. कंपनी जब स्टार्ट हुई थी in 2005 in New Zealand, जहाँ पे Dr. Sean Simpson and his colleague they started working on these gases from the industry. तो वो लोग स्टील मिल में जाके वहाँ की फर्नेसेस से दे कलेक्टेड द गैसेस एंड देन they worked in the lab using certain bioorganisms, which we now call biocatalysts. And these microorganisms, they were living on these gases. They would eat the gases and give out product like ethanol. And so first projects that started with LanzaTech technology, they were in the steel mill sector in China, Taiwan. There were multiple demo scale units started, and 2018 में commercial scale units started producing ethanol from gases in the steel mill. Last year, second unit has started. This year, we are expecting one unit will start at Indian Oil Refinery, where the off gases will be converted to ethanol, and there is another unit in Belgium, ArcelorMittal steel mills, जो उनका गेंट plant है वहाँ पे it will be starting and converting that into ethanol. So that's the first biocatalyst which we are using to produce these chemicals. Next. Then LanzaTech has also been working to see how other feedstock which contain carbon can be converted into ethanol. Agricultural waste, municipal solid waste. In Japan, we have a unit, a pilot scale demonstration where municipal solid waste, which was a gasification process and has been running for a long time. So वहाँ पे we had taken a slipstream and then that was used to produce ethanol, and now they are scaling it into a larger unit. Next. So what it does is, if you see on the right side, there are a lot of products which at the end of their life they get into the municipal solid waste, and they can be gasified, and we are completing the cycle again. Next. Next. The other pathway that LanzaTech has been able to work is today there is a discussion on green hydrogen, and there is also work happening to convert CO2 electrolytically into CO. Once we have green hydrogen and CO2, we can convert that using the same process into ethanol. Next. So what happens is when the fuels are burned, there is carbon getting released into the atmosphere, and this can be captured. There are now direct air capture processes also, and with with green hydrogen, this can be again converted into ethanol. So we keep recycling the same carbon, and that can reduce our dependence on the carbon which is below the ground. On the right side, you also see we are talking about proteins and we are talking about other chemicals. So one of the byproducts from this process is, since microbes continuously keep growing, we take them out, and this dead microbe is also a big source of protein and can go into animal feed. And this ethanol can be converted into chemicals. There are many pathways: ethanol to ethylene, to polyethylene and MEG, which are basic raw materials for making polyester and other plastic products. Next. So the further development that LanzaTech is having is seeing what other than ethanol can be produced. So we have many more strains, and we are with the same process, just by changing the microbe, we can produce chemicals like acetone, IPA, and MEG. Next. So, as I mentioned, our first unit started in 2018 and it has been certified by RSP as a biological process, and more than 190,000 tons of carbon dioxide has been avoided since it has been in production. Next. This is a picture from the unit in China where this ethanol is being produced now. Next. Data from that unit which shows even with varying feed, it continuously operates in a stable form. This is the first commercial scale gas fermentation project in the world. Next. Picture from a unit which is coming up in Belgium and will get commissioned towards the end of this year. Next, please. So we expect more than 64,000 metric tons of bioethanol production per annum, and expect to mitigate more than 350,000 tons of CO2 per year when the production starts. Next. Project in Japan where we ran this pilot unit for almost 4 years, where unsorted municipal solid waste was gasified, and then the syngas generated from that municipal solid waste was converted into ethanol. This is now being scaled up into a larger project, and mechanical completion has been done. Now it's in the commissioning phase, and this will lead to multiple units in Japan based on municipal solid waste and getting converted into ethanol and further downstream into downstream chemicals. Next, please. A picture on how the project is getting, how the technology is getting commercialized. We have projects in India coming up at Indian Oil Refinery. There's one project that we have designed for MRPL, and hopefully this will go into execution phase very soon. This takes agricultural waste like cotton stalk and corn cob, and that will get converted into syngas and then into ethanol. Multiple projects in China. There's also a project in Europe where CO2 and hydrogen will be used to convert into ethanol, and that ethanol will be converted into sustainable aviation fuel. Next. This ethanol has not only been used as fuel, it has also been used by many of the brands. We brought this ethanol from China into India and converted that into products like ethoxylates and MEG. Ethoxylates have gone into many of the formulations and detergents, whereas MEG has been converted into polyester yarn, and it has gone into fabrics to produce for use by companies like Zara and Lululemon into their products, making making a statement that the carbon can be recycled and they can be used for meeting our daily requirements. Also, a lot of packaging, polyester packaging, PET chips, they have been made using this MEG. Next, please. We are very strong in synthetic biology, and as I mentioned, we can make many more strains which can be used to make many more chemicals. Next. I'll quickly skip through these slides, not taking much of time. LanzaTech has developed many processes and using artificial intelligence, computer-aided designs, and genetic engineering. We have created many new processes to reach the stage where we are today, and it will help in strengthening the biological processes that can be used to develop further products which are needed by or to meet our daily requirements and many more needs of the industry. Next, please. Next. One of the things we call it's a world first anaerobic biofoundry. So this is our strength where we can test many strains of microbes using artificial intelligence and genetic engineering. The capability to test the strains or this has grown exponentially for us, and which has helped in developing the processes. Next, please. So what we are saying today is that when you start with the hardware of producing ethanol, the same plant can in the future produce more different products like acetone. We have been able to show that, and it's going into a piloting stage. It's in the piloting stage and will be commercial very soon. Next. Then we are working on IPA, which again will be offered as a commercial technology in the very near future. Next. MEG also is one of the next products, and where we have tied up with company like Denon, who have a lot of packaging material, where we would like to recycle the carbon dioxide and make the products using gas fermentation process. It cuts down on the overall carbon footprint. Next, please. And then many more products down the line. Next. Next. Next, yeah. So a lot of waste resources that we talked about, it's the emissions from the steel mills, it's off gases from the refineries, it's the agricultural residue, municipal solid waste, and now also CO2 from direct air capture. Next, please. So, next. So one of the process that Lanza Tech has been able to scale up, and we have another company, LanzaJet, which is into sustainable aviation fuel. What we do is take the ethanol, convert that into ethylene, and then to higher hydrocarbons, finally leading to jet fuel and also diesel, which can be made from this process. Next. There are multiple projects. Next. Where which are coming up in Europe and other locations. One commercial flight, it was done by Virgin transatlantic flight, where Virgin they flew it from US to London, and you can see on the pictures Richard Branson and LanzaTech CEO Jennifer Holmgren. She was on this flight, and now we are scaling up the process and building up units so that this fuel would be available to the aviation industry. Next, please. Next. 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 So a lot of work that has been done to ensure that the jet fuel is certified, and then it can be used by the aviation industry. Next, please. Some of the partners who have invested into this sustainable aviation fuel: Mitsui, Shell, British Airways, ANA, US Department of Energy. We also are working with Indian Oil, and they are in fact one of the investors into LanzaTech. And our first project in India is coming up at Indian Oil Panipat Refinery, and we are working with how to build a sustainable aviation fuel in India. So hopefully we will have more to talk about in next few months. Next, please. Next. 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 So just to complete the loop, so what we say is carbon can be recycled, and it used to provide our needs of fuels and chemicals. I'll just break at this point, and any questions I would.
I think question session should be in the last,
Sure.
right? Thank you, Mr. Sangeet. I think Mr. Mahawar will like to throw a light on what is the work we are sitting here. What is the work on your side?
The main purpose of this conference is we wanted to bring the new technologies and things which are happening. I think this recycling of carbon is a new concept. I compliment LanzaTech for this. I think this is a good initiative. And sustainable aviation fuel. It's a new thing which has come up. And I think, as he has said, and Indira is already in this process. And with the time, all other companies will definitely tie up with them, and I hope that this will also make a way in India. Thank you very much for that.
Shrey will like to talk about what they are doing at Grow Diesel. I think you can sit and talk.
Sure, definitely. So very green afternoon to all of you. I would really like to thank Agarwal sir and Bhattacharya sir for having me over here. So थोड़ा सा मैं background बता देता हूँ आपको that हम क्या कर रहे हैं, and जो मेरा topic था it was biofuel and its sources. So story dates back to the year 2008. 2008 में हमारी टीम ने realize करा that anything that has hydrogen and carbon can be converted into fuel. And waste was one of the biggest sources which was abundantly available. कचरा बहुत ज्यादा मात्रा में अवेलेबल था. चलिए अगर मैं आपसे एक क्वेश्चन पूछूं, रोज दिल्ली में कितना मेट्रिक टन कचरा जनरेट होता है? Will anyone like to answer that? Any number? कितना मेट्रिक टन कचरा जनरेट होता है? Any answers? Okay, so you're close. Close. 12,000. Around 12,000 metric tons of waste is what our city generates every single day. Now, 51% of this waste is the organic waste. Around 30% is the recyclables, and the rest is the inert waste. Now, how about this? If all this waste can be converted into fuel and green energy, the amount of reduction that we will have in our crude oil imports, it will be huge. So when in 2010, when our team started working on this particular sector, we started to analyze कि already market में कौन-कौन सी technologies available हैं. तो हमने डिस्कवर करा कि बायोगैस एक ऐसी टेक्नोलॉजी है जो बहुत ही सालों से हमारे देश में एग्जिस्ट करती है. नाउ इस टेक्नोलॉजी की अगर हम बात करें तो इसमें एक फंडामेंटल सबसे बड़ा जो चैलेंज था कि बायोगैस जो ट्रेडिशनल डाइजेस्टर सिस्टम्स होते हैं उसको हम मल्टी फीड पे नहीं चला सकते. मान लीजिए अगर मैं उसको काउडंग पे चला रहा हूं, सिर्फ काउडंग पे ही चला रहा हूं, तो वो काउडंग पे बहुत सक्सेसफुली रन करेगा. बट किसी दिन मैंने उसमें कुछ अलग कचरा डाल दिया, मान लीजिए पराली डाल दी, या फिर मैंने स्लॉटर हाउस वेस्ट डाल दिया, कोई और सोर्स ऑफ ऑर्गेनिक वेस्ट डाल दिया, तो वो नहीं चलती. सो वी स्टार्टेड वर्किंग ऑन मल्टी फीड रिएक्टर बेस्ड टेक्नोलॉजी. तो बायोगैस के जो 4 मेजर प्रोसेस होते हैं, हाइड्रोलिसिस, एसिडोजेनेसिस, एसीटोजेनेसिस एंड मीथेनोजेनेसिस, हम इनको 4 अलग रिएक्टर्स में परफॉर्म करते हैं. एंड इसकी हमने एक प्रेजेंटेशन दी थी 2010 में पुरानी मुख्यमंत्री शीला दीक्षित मैडम जी को. एंड उस प्रेजेंटेशन में ऑल द टॉप ब्यूरोक्रेट्स ऑफ दिल्ली अलॉन्ग विद सीएम मैम वर सिटिंग. After the presentation, madam ने मेरे my father is behind this organization. तो she told my father that मैं पिछले 15 साल से दिल्ली में हूँ, कचरे के ऊपर बहुत लोग बात करके आए और चले गए, लेकिन कोई कुछ काम नहीं हुआ. To which my father said, मैडम आप हमें एक मौका देके देखिए, अगर प्लांट चल गया तो आपका, वरना हम इसे उठा के ले जाएंगे. तो मैडम ने कहा ठीक है, आप इसको हमारे ऑफिस में लगा दो, मैं इसे रोज देखूंगी. And I'm talking about August 2010, and we'll be completing the 12th year of that project this August. Post that, we have worked with Maharashtra government, Haryana government, and various other organizations. And I feel proud that till date, Crow Diesel has been able to convert more than 250,000 metric tons of waste into biofuel. And very recently, I was awarded the prestigious Dyna Award by the British royal family for this innovative initiative. So this is the sum of the work that we have been doing.
Thank you very much. I know about your company since a long time because this was the NDMC project, long time when your father met me. I think मिश्रा जी आप कुछ कहना चाहेंगे? हाँ जरूर जरूर जरूर. You have a presentation? एक मिनट को यार.
Very good afternoon. I am really thankful to Deendayal Agrawal ji, Mahavar ji, for inviting me to deliver a lecture or share the experiences with respect to the hydropower. See, though we have discussed the other forms of the power available through different sources, but hydro is also playing a very important role in the energy mix. And this realization is now trickling down. The reason is that as we move towards more solar and wind, we have to have a dependable complement source, especially for the night. Because what is happening is that you generate the power in the day through solar and wind, but remaining 12 hours, that is evening till next day morning, you are not having that source available to you and you need a supplement. Supplement comes through hydro. That is the nutshell story. The hydro sector never got a top priority in the system because the execution time for a hydro project on an average in our country, if you look the past background, is average is more than 10 years. And there are exceptional cases when the project has taken even 15 years, even more than 15 years. So there was no attraction, neither in the planners nor in the political system, to encourage these projects. But now the time has come when the project construction time is getting reduced. And the project which I have recently done in Bhutan, this is a 720 megawatt project named Magdechu hydroelectric project, is a bilateral project, totally funded by Government of India. The total money is divided into two components: 70% loan to Government of Bhutan at 10% simple interest, 30% grant. The project has been completed in a span of 7 years and at a cost of 5,110 crores. 5,110 crores. This gives you the confidence that projects can be done in a given time and a given cost. Now, another important thing which I would like to highlight here is basically that India, Bhutan, and Nepal. If you look at our country, as per the CA data, the assessed potential at 60% load factor (PLF) is about 1,48,000 in India. What has been assessed by CA, and if you look at Nepal, it is about 80,000 megawatt. And if you look at Bhutan, it is 22,000 megawatt. I am talking exploitable energy or exploitable hydro potential. Theoretical must be slightly higher. Now, if you integrate these three together, India, Nepal, Bhutan, you can definitely plan something like 250,000 megawatt. Today, if you look at, I'm talking the CA data, on 31st May 2022, our installed capacity is higher than 4 lakh megawatt, in which hydro is just 10%, renewables about 28%. Now the question is that in 75 years, we have achieved 4 lakh plus megawatt installed capacity.